Alright, in this video we're going to be talking about the graphing calculator app that you can download to your smartphone. So there's a Calculate 84 that I've been using. I like this app. It's very similar to just a basic graphing calculator that I've used in my past. So that's the one I chose, but you may choose another one. So that's not critical, but it's the one I'm going to demonstrate with. So if you want to take some time, pause the video, and this is what it looked like when I went into my app store, Calculate 84. Now if you're on an Android, I believe this one may not be present, so you'll need to download Class Calc. There's another app called Class Calc that I like. And you might just shop around for some and see what you like. So they all have their different pluses and minuses. So this is what it will look like when you open up the application. It looks exactly like a graphing calculator that costs, anywhere around $100 to $200. So it's free on your smartphone. And I think it's maybe even better because you can touchscreen. You can move the points around with the touchscreen where you can't on your regular handheld. Also, I guess the other maybe negative is if you're taking the ACT, you cannot use your smartphone, so you would need a handheld. But if you learn on one that's very similar, it should be easy to borrow or check out one from the library to use a handheld then to take into testings that don't allow smartphones. All right, so once you have downloaded that, let me show you what it looks like on my smartphone. Oh, let's see. So here is Calc 84 when I'm that, and it takes up the whole, view of my smartphone. And the first main function button, y equals. We're going to talk about this first row function. Y equals is our input. It gives you multiple y equals, but we'll probably just do one at a time. But you could do multiple equations and graph them on the same screen. All right. So this y allows you equation, and whenever you input an equation, a lot of times there's an x variable, so you'll want to use it's the button that looks like this, xt theta n. So on my calculator, I don't know if you can see that. It looks like that. Let me get out of that. Okay, the x. That will make the x as the default when it's in the mode for the first one. So the typical standard mode will pick up the x value, and that's how we'll type in our y equals. Next, the window button you see here allows you to adjust. The default is it's a -10. If you were drawing on your paper an x-axis, a y-axis, and you tick mark back 10 and then over 10, up 10 and down 10, a 10 by 10 grid, that's the default. Also, the X scale is 1 and the Y scale is 1, which means they're counting by ones, which is typical. Our most basic graphing that we do, we count by ones. All of that can be changed. For example, and we're going to practice that today, we could clear that out and say, well, I want it to go to -20. And maybe to +20. And let's count by twos. You can do all of that. You can do that on the X scale and not on the Y scale, or do it on both. You can adjust this in any way that you want. But, okay, back to that. So that's your window screen. Zoom sort of does the window for you. It'll zoom in and out, so you can zoom in on your graph. I don't have a graph there, but you can also pinch and drag graphs to zoom as well. So zooming will allow you to make the picture bigger, zooming in and out, and also there's a zoom standard, which will always take you back to the 10 by 10. So standard is the 10 by 10 that comes along with it. So if you ever get messed up and you need to go back to your 10 by 10, you can do that. Or I think if you just turn the app off and come back into the button trace will let you move your cursor around the screen. You do that either with sideways up and down buttons to trace or with the touch. And then lastly, graph. Whenever we're going to equation, we'll hit graph. It'll show up on this. So those are the function buttons. You have this handout also in some of your modules. So I'll also post it there. Second feature. So, and this is hard to see, so I apologize, but over top of that, and maybe you can see that better than I can, but that's very small and it's in blue, but there are words above: stat plot, table setup, format, CALC calculate, and table are the second functions. To get second to work, you have to hit the second button and y equals, and it brings up stat plot. I don't use that much, but it changes it from solid to dotted and various things, like the display of what the graph looks like. Table setup is over window, and that's a place that we can change our t-table. If you were making a t-table, you would draw out like an X and a Y t-table. And a lot of times we start with 0. We say 0, 1, 2, 3. But if we had some crazy big numbers like y equals 500x plus 30 or something, that would be hard to show on a regular t-table. We might need to start with bigger numbers. So this says we can make our table start at 500 if we want, or we can make it start at negative 200 if we want. So that tells the table where to start and whether we want to count by ones. Sometimes we want to count by fractions because we need to see like what happens at a half or at a third. So the default is it starts at that 10 by 10 typical numbers, and it counts by ones. But we can change all that here in the setup. So I'm going to change that back to counting by ones, and I'm going to tell it to start at, what did it say before, 0? Maybe. All right, so that's table. Then we have format. I never use format. And then calculate. So I wanted to show you calculate is the fourth button over. We use to find a lot of fine details on our graph. We can find a value, but a thing we a lot of times are looking for the 0, which means the place crosses the X intercepts are the zeros. You can see that here in my note. X intercept 0. The setup forces you to pick a left bound, hit enter, hit right bound, enter before giving you the answer. We'll talk about that in a minute. The process your X intercepts under calculate. The next one, minimum, maximum. Oh, and you can see that left bound. Can you see that on my screen? If I would have had a graph here, it makes me go to the left side of where I think the X intercept is, hit enter, and then arrow over to the right side, hit enter before it tells me. So it asks you, kind of interacts, asks you a question. Also in calculate, there's minimum and maximum. We'll use those when we talk about parabolas. Intersect will help you in chapter 5 when you're looking for where two graphs cross one another. And that's the main thing we use. And then E, this is very handy. E part is your table. This is your t-table of values. So I think I messed up my table setup over here back in the beginning. Did I do that? Yeah. Okay, so we should be able to see our X and Y values there. All right, so those are your main function buttons. So we've got some activities to practice. So take some time, make sure you've got that downloaded, and we're going to practice graphing a linear equation first. 2x minus 3y equals 12. So first of all, if we were going to put that in our graphing calculator, you've got to solve it for y before we can use this feature. So you'll have to do a little algebra to get it to help you. So you have to throw the 2x across the line and divide by -3. Rearrange that. You get y equals 2/3 x minus 4. So let's practice. Take a minute and let's all get that plugged in. Y equals, so 2/3. Remember the x is there, minus 4, and then hit graph. I need to get out of all those calculates. I might have to reset mine because I can see it's still got some old stuff on there where I was playing with it from before. But say we practice finding that x-intercept. It looks like, here's the x-axis. It looks like it intercepts or crosses the x-axis right there. So go to the left side of it. Then it asks me to cursor over to the right side. Go somewhere anywhere to the other side of it. Hit enter, and there it will tell me. So the 0 is at x equals 6. And we may have thought kind of putting our cursor over that and thinking it kind of looks like that's about 6 units over. So so some activities would use trace to go along this line, either with your screen or use trace and arrow. You can use the arrow on trace, and I think I'm kind of trying to check to see if that's the x-intercept. Sometimes the pixels aren't set up to be perfect algebraically, and sometimes they are, so just be aware of that. I can't seem to get it to hit exactly at 6 in that way, but it kind of looks like y is almost at 0 there, and x is almost at 6, but you're not always able to tell exactly using that trace feature. If I want to know for sure, a couple of things. You can calculate the 0 to determine the X intercept by putting in y equals 0 here. When y is 0, 2x equals 12, and when we divide by 2, we get the x is 6. So we can do that by plugging in y equals 0. And we can use calculate. Okay, that's what I wanted to show you. When you hit calculate to find exactly where a 0 is, you hit 0, enter. It makes you do that left bound, enter. Go over to the right bound, enter, and then it will tell you exactly without the pixel issues there. It will say, here's the 0. Here's an XY point that you're currently got your cursor on. It gives you that as well, like a T-table point. And then underneath that, where it says 0. 0 is at 6, and that verifies that. You can also do it by looking at your table of values. So there's that T-table I mentioned. Let's look. It should be when y is 0. Let's see if I can find that. Well, let's go this way. So we can kind of explore our T-table of values and find these are points on the graph. That's a nice point. That's the y-intercept if you wanted to find that. When x is 0, that's when the y-intercept occurs. Here's when x is 2. Here's when x is 3, y is negative 2. All right, let's keep looking up this. Y is 0, x is 6. That also confirms with our T-table of values. And then I ask you 6 to verify some points. Plug in a point. There's a lot of decimal value points here, but how about this 3, negative 2? I want to check to see if 3, negative 2 is a solution. We can go back to our original equation, 2x minus 3y equals 12, just to show you that these are true things that relate to this. It says when x is 3, y is negative 2 works. That's a point on the graph. So that's 6, and then minus 3 minus 2 makes positive 6. And there it verifies. These are our solutions, or our points that solve this equation. We could pick others to show. Also, an activity was practicing the 20 by 20 and counting by 2s. I think we've already talked about that now, though. And then changing your back, you can change your window always back by standard. So say you looked at this graph and you're like, some graphs aren't as going through the 10 by 10 graph, so we have to do some playing around with the windows to get it to fit. But this one's fine, and we can see it in the window, but say we couldn't. We could go to window and adjust, like I said, and make it a negative 20 by 20, or whatever you thought it needed to be. And I see I still have it scaled by 2s. I meant to change that back. I'm going to scale it by 1, counting by 1s. But here's where all of that can be rearranged if needed. And now let's look at it with a 20 by 20. So now you can see we got a 20 by 20 grid instead of 10 by 10. So you can adjust that as needed. Then we can go back to zoom in and out, but zoom standard will always take it back to our 10 by 10 grid. All right, we'll continue talking about this graphing calculator app and come back and work some other types of equations.